Hi everyone. So today I just want to go over a couple definitions with you guys, as well as go over the drive of the Michaelis-Menten equation. So first I'm going to go over what Km is. Km is a substrate constant that gives half maximal velocity of enzymatic reaction. If a Km is low, then there is a high affinity. If the Km is higher, there is a lower affinity. Then I'm going to go over the Vmax. So a Vmax is the maximum velocity or rate at which the enzyme catalyzed a reaction. It happens when all the enzyme active sites are saturated with substrate. So now I'm going to go over the derived Michaelis-Menten equation. Okay, so we have the E, which is an enzyme, and adding together with the substrate to get a enzyme substrate complex. So in this first reaction we have the double arrows, as you can see, which means that the reaction can proceed both forward and backwards. So the next part is the second part of the reaction. We have that enzyme substrate complex, and it breaks apart, giving us an enzyme and then a product. In this reaction, you see that there is only a single arrow, not one that goes backwards and forwards. That is because by the end of the reaction, there's not enough product to reverse the reaction. With these reactions, I gave the rate constants a variable. We have K1 as one of them, then we have K-1 as the backwards reaction, and K2 as just the forward reaction for this. To make sure that the equations are negligible, we add the two together to then, we notice that the two ESS will cancel out, leaving us with two enzymes, leaving us with the net reaction, the substrate. So we are going to make a steady state approximation, which means that the creation of the enzyme is equal to the sum of all reactions decreasing its concentration. We write this as an instantaneous rate of change for ES over dt, which equals the reaction of K1 times concentration E times concentration S minus K-1 times ES minus K2 times ES, and all of this equals 0. This reaction mirrors our method of initial rates, where reaction only depends on the concentration of the reactant. So it is difficult to determine the value of unbounded enzyme E. To solve for this, we write it out in this equation. Once we find the concentration of what the enzyme E is, we can plug it into our next equation down here. Our goal is to solve for the concentration of ES. So we are going to move ES from all parts of the equation onto the other side. We divide ES by itself to arrive at a concentration. So ES equals this equation. So when we work the problem out, we're going to end up with this down here at the bottom. So the instantaneous rate of change for the product is a function of its reaction in this equation. With this equation, we can plug in what we have from the other what ES equals, into this second equation. Now we are left with the equation for velocity, which is just another way of saying the reaction rate. In this reaction, we can see that there is kcat on there, which is also another term for Km, which I have defined earlier in this video. The kcat, also known as K2, can also be referred to as the turnover number. It is the maximum number of molecules of substrate S that an enzyme can convert to product per catalytic site per unit. So we have the total concentration of enzyme times the maximum number of molecules an enzyme can catalyze per second if all the enzyme is reacting with the most molecules possible per second. We have the maximum rate signified by v velocity max. I hope that this helped you guys, okay? Have a good one.